when I moved from SUSE to university back, I basically also switched to the dark side of programming. No, not using Windows or any proprietary crap, but yeah, like I'm now using the stuff this group is actually working on typically. And so I'm the bad user here. And that's why I want to talk about what I'm using the software rasterizer in Mesa for and why, and what implications that had. And it basically means that using real graphics hardware is pretty bad for teaching, because you have to deal with so many unknowns. There are known unknowns and unknown unknowns. And basically this talk is about obsolescence. Everything about this talk, including the talk. And it's either already being obsolete or getting to the state of being obsolete. I mean, if you've seen me yesterday, I wore a core protocol t-shirt, you know, that one with the X.Org logo with jaggies. And now I'm wearing OpenGL 3, which is also pretty damn old. So yeah, I'm obsolete as well. And where do we have obsolescence? OpenGL, it's basically the version we are currently supporting. I mean, we currently support only OpenGL 3.1, and which is basically, the spec has been available for more than 4 years now, as I talked yesterday. And the main issue is that even on the Corona's website, the only quick reference docs you actually get is, the oldest one is about OpenGL 3.2, and the GLSL even about 3.30. So if you want to have any docs for your students to actually use, you have sort of a mismatch. And also, yeah, I'll come to that. And actually the difference in GLSL is actually hurting us much more than the ones in OpenGL, because, well, most of the functionality in about 4.0 actually is even present in OpenGL, but we can't compile any GLSL programs. Actually, we can, but come to that later with some dirty tricks. And something like attribute location binding, having in the code itself, in the shader code itself, is very, very helpful, especially for some semantic reasons. And yeah, of course, the supported version in Mesa is also driver dependent. This is one of the main issues. Of course, we won't get rid of that, but we can try. And also, this talk is about a little bit obsolete, because after quite some discussions with Ian yesterday, I sort of find some solution-ish things I can work with, but I'm not exactly sure which one of those will be the right ones, so this is up to this discussion, but I'll come to that soon. Yeah, graphics driver. Should we use one? Nah. In real life, yes, of course. You don't want to play games without graphics drivers. For teaching, no, you won't, at least not in the beginner's class, because there are version differences of the OpenGL stack between different graphics stack vendors. If you think of Mesa of one single vendor, we even have different versions within a vendor for different drivers. We have behavioral differences between the different graphic drivers, and even within one vendor or even one hardware vendor, we have behavioral difference between different cards. I mean, old and new rating cards don't exactly behave the same, do they? And of course, we have different bugs. We always have. And that's why for teaching, I rather like to stick to the software rasterizer, at least in the beginner's class. I mean, if a student is in his second year and you have to tell him about OpenGL versioning and core profile and versus compatibility profile, and about what to do if one thing isn't working and use extensions and so on. I think he's going crazy. We always think about that we need to use the graphic because of one single thing, speed. And actually in teaching, this is not an issue, because you can guess what is about the most complex geometry views we ever use? Yay! Why is that? Because we all know in computer graphics we only deal with single primitives, because anything else is just a repeated process after that, and the keyboard is a primitive. Of course it is. Yeah, okay, I'm sort of fooling around here. It's glatt keyboard, but yeah, glatt solid keyboard. Yeah, and the fascinating thing is that nowadays the software rasterization is actually almost always fast enough for that to be really interactive. Speed is actually pretty amazing. I don't have real numbers here, just have experience points over the time where I actually checked that. I remember the early times, just as we heard day before yesterday, when basically OpenGL started, or even before that with RSGL. Gosh, I didn't really remember that interface was that broken, but it was, yes. And at these early times, even flat shaded triangles were way too slow to do anything useful with that. I remember that when I worked on Mach test, which was an OpenGL speed testing program in the beginning of the century, that at some point of time I tested it versus the software rasterization of Mesa versus I think it was the NVIDIA driver back then. And oh my gosh, they were about 3 times as fast in software than they were with hardware. This was amazing. So this is definitely fast enough. Smooth shaded triangles were also reasonably fast enough already back then for teaching, and reasonably even textured triangles are really fast because the CPUs have advanced so much. And nowadays you can even use shaders reasonably just for studying, because of course in a complex thing that will be way too slow, but LLVM really helped a lot here. Feature-wise, this has only been recently an option, because before actually Mesa 9.2 shipped out, you remember, this is really very recently, we had, as soon as we took a software rasterizer, we only had GL SL 1.20, and especially in these early versions of the GL shader language, quite some things changed. I mean, 1.30 is really not where we want to be at, but it's at least a bit better than 1.20. And we also got only GL version 2.1 with the software rasterizer. Well, that hadn't changed, but at least the GL SL is now on the same level. I suppose that I get a better OpenGL version even with the software rasterizer with Mesa 9.2, as far as I understood some of the news, but if I take a look at the feature tables, I think there are still some pieces missing for 3.0 actually to be announced. I'm not exactly sure. I thought I had seen 3.0, but somehow that vanished. Yes? The mic?
If you're using LLVM pipe, I'm reasonably sure that you're not going to get 3.0 because it doesn't have float buffers.
Right, yeah. But I think I tested something and I got 3.0, so I probably was testing something wrong. I think this happened.
Or the software driver just is buggy, which,
yeah,
you know, that never happens.
But, well, I'm almost not anymore, but I still do make mistakes. Okay.
Thank you, Dave.
Right. Yeah, right, that's also one issue. Yeah, so the good question is that only for teaching. I'm talking about only for teaching, not for really full-blown software development, because I know what to do there. There I would actually have to check the extensions and just deal with it that I only get 2.1 and or maybe 3.0, whatever, and I have the extensions so I know what I can actually use. But would it be wise to actually use MesoGL version override in a controlled environment where I actually know what version of Mesa I'm using? Or is this way, way too hacky? What do you think?
So I think for the particular case that you have here, where you're trying to use a software rasterizer that's just missing one feature that you're not going to use anyway, that the version override is fine. So about your next point, the missing functionality wiki is miserably out of date, and I believe that docs.gl3.txt is, people keep it fairly reasonable, but it may not always be correct about which hardware supports which features. But it is correct about which things are completely gone and which things are,
it's
at least supported on some drivers.
Yeah, feature matrices are actually a really nice thing to have if they're current and correct.
Yeah, and
that is a pain in the ass to actually keep up.
Yeah, and I would love to have some student project to make a thing for Mesa drivers that's kind of like the giant matrix that Apple publishes for all of their hardware and different OS versions. It's really nice, and it doesn't seem like it would be that much work, but it seems way too tedious for me to want to do.
And it would also be good if you had some matrix where it was also indicated which version of OpenGL could be supported, because the hardware actually supports it, all the features that are required, which aren't there. Yeah, so this is really a big issue from users' point of view, but yeah, I see that we are still understaffed to actually deal properly with that. So, but it's good to know that the one in the actual source tree is reasonably polished. So that's the one I'll actually think about. Right. That's good thing to say, but in this particular case, it's actually pretty good, because I only want to use core profile anyway. I mean, if I'm thinking about using 3.1, which is the most recent version supported by Mesa anyway, then I have to stick to the core profile anyway, and for the future ones anyway as well. But this is also one other thing I want to talk about. But let's refer that to the next slide. At least for teaching, we won't need OpenGL 4.4 or something like in that area soonish. Even though I said that it might come earlier than we think, eventually. But one of these days, yeah. But actually having OpenGL 3.3, rather actually GLSL 3.30 is very, very reasonable to have. Not only because finally the version numbers match. That was so broken in the old specs.
I'm really, really sorry.
I don't think that's your fault. Is it?
Maybe a little bit. I get at least a little blame.
Okay. Yeah, you were part of the group at that time. Yeah, right. Okay, because for those who are not that familiar with that, in GLSL 3.30 you can actually bind certain attributes to certain attribute containers, which are numbered, which is so much nicer to have in the shading language itself, because it semantically actually fits in there, rather than actually have that the variable specified without that location and do the location binding afterwards doing linking. It's still usable, yeah, but it's just much nicer to have that semantically in the right place. And it's the more important thing is probably more that the documentation on opengl.org is really only useful for 3.30 and up. The specs are there, but no quick references and so on and so on. Actually, it's pretty much implemented as far as I understand, but it's just not exported to to the user space. So if I choose to use GLSL version override to 3.30, then I should actually be able to do that. Is that correct?
Should. I mean, you can do it anyway using the extension.
Yeah, it's only syntactic sugar anyway. But if
Right,
I
right.
think again about trying to teach to second-year students about
Yep.
extensions
I've been there, done that.
and actually multiple positions where I could put these extensions in the shader, in the code, and so, etc., then no, I'd rather not go there. Or should we probably better wait for 10.0 to actually have that? Oops, I haven't tried it so far, yeah, but it's just a theoretical point of view. Okay-ish. Yeah, then I'll probably stick with the last line here and wait for 10.0. Yeah. I don't think I will update all the laptops in our lab with latest master code again. Yeah, I actually want something that is stable, at least time slot-wise. Yeah, right. Fair enough, yeah. That could actually, if this is just fixed, this particular one is just a fixed amount of code, yeah, then we can actually deal with that. Okay, and one more thing which is really bothering him a lot is that what you typically, from an applications point of view, you actually want to be able to do is to create the most, a context with the most recent version of OpenGL you, as a programmer, didn't know at the time of programming. And you're able to deal with some lower versions. So say you code something at the current point of time, so then you say something, oh, I want the most recent OpenGL context starting with 3.1 and up to 4.4, and you want to get the most recent context. And after that, you check which version did you get and decide about render paths and so on. And as the moment, as far as I can see, the only thing possibility to do that is to actually loop over the different versions and try to create a context, catch the GLX error, and if there's an error, then just continue the loop until you get one. Is there any saner thing to do?
Dave might have a comment about this because he did something really similar in GLX info where
I was looking at the GLX info code. Yeah.
Is that what this does? It starts with. So you probably shouldn't have to do that. I think you should only. I would say that there's probably at most 3 checks that you would need to do. One would be try to create a 3.2 core profile and then check and see what version you get, because all of the versions after 3.2 are backwards compatible. So if you ask for 3.2 and the driver supports 4.4, it will just give you a 4.4 context.
Oh, so you really get one of the newer ones? Okay.
And then the other thing to check would be try just asking for a 3.1 context, because for 3.1 there were no profiles yet, and then ask for just an any, and see what it gives you, and then it'll give you a compatibility.
Get an OpenGL 4.4 core protocol context if you ask for 3.2.
Right. So what you're asking for basically is you're saying a minimum version, and it can give you anything that's backwards compatible with that.
okay, because I thought we would get the exact version
No.
because at least with 3.1, 3.0, 3.1, 3.2, we actually reduced functionality. So
No, there was nothing removed in 3.0, and
for beginning
so
from 3.0, I mean.
So yeah, and so then with 3.1, and that's why I was saying you
Yeah.
could also try asking for a 3.1 because, like our implementation, we don't support the ARB compatibility extension. Over my dead body, Dave. We don't support the ARB compatibility extension. So if you ask, you won't get that unless you specifically ask for that version.
Because Mesa only supports 3.1, I actually couldn't test that
Right.
because I just tried to open 3.0 with core protocol.
Right.
This, of
Well,
course,
you
doesn't
didn't. You can't say
exist.
3.0 with core.
Yeah, because
right,
it
because
doesn't
there's no such
exist.
thing.
But then you only get 3.0, and
Right.
you don't get 3.3 or something like that.
Right. Right. So if you ask
It was
for
kind of funny.
yeah, so if you ask for 3.1 and don't, yeah, 3.1 was mistakes were made.
Okay, so there is a best practice about that. Then it's good to know. But still, you actually have to go through the hassle of actually getting chill X hours and so on. So, but yeah, that'll be. Yeah, so I don't want to bore you too much. Yeah, okay.
So the logic tree for that is really easy to forget because we even forget it very often. If you go to the GOX create context spec, there's a little tiny if tree in the text that encapsulates that knowledge that you need.
Okay, the specs of the FCHIL X, how's this?
It's the GOX AR.
Okay, yeah.
Sure, okay.
Okay, yeah. Thanks. Okay, so I don't want to bore you any longer because with user space stuff. So basically, the results are that the LLVM software driver is actually in a reasonable-ish state to use for teaching shaders. Actually, we could use a little bit higher versions there, but yeah, we know MPA won't happen soon for software rasterizer because writing code for the software rasterizer is probably less sexy than providing hardware drivers. And less useful, yes. But I still stick with less sexy because this is about attracts more people for actually coding. Support for GLSL 3.30 out of the box would be awesome. And as far as I understood, it will come soonish. But the question was rather, is it really required to not expose GLSL levels that aren't typically available in the announced OpenGL level because the GLSL has information about features that are not yet supported by the according OpenGL level? Or could we just go ahead and allow 3.30 GLSL code to compile even though we only have a 3.1 core context?
So we ended up not making 1.40 available because it included some features that we didn't want to do compatibility
yeah.
interactions with. And Paul and I had a long conversation and a lot of head scratching about 1.50 and 3.30 is just syntactic sugar on top of 1.50 about whether or not it was valid to advertise that on, say, a 3.1 context.
Right.
And I think the conclusion that we came to was that so much of the stuff that was added in 1.50 is so intertwined with geometry shaders that you couldn't really do one without the other. So, and if we have geometry shaders, well, then we have at least 3.20. So the discussion becomes moot. And that was,
Okay.
I don't know if Paul's.
I'm not sure that we ever reached a consensus on that.
Okay. Yeah, I remember that we kind of just. Well, I mean, I wanted to go ahead and expose it, right? I wanted to do this, but it seemed like work and like there was some weird stuff about it, but mean, we could.
My bigger fear is the compatibility.
Well, so I think, I mean, if we just expose it on 3.1, where we don't have compatibility mode.
Right, that was also what I was thinking about. If you get
Yeah.
a 3.1 core profile context, then you, and then, I mean, if you just ask for which GLSL version is actually supported, then with 3.1, of course, you only get it 1.30. But if you just feed some hash version 350 to the compiler, should it really bail out, or should it just say, okay, crap, that's not really true, but well, I'll compile it anyway?
In general, we don't slop stuff through.
Yeah.
We'll, some other vendors do that, and we hate life because they do that. Because then
Okay.
we get shittily written apps that say, well, it works on the other guy, and we tell them tough crap.
Yeah, right. That's
So I'm
one
not
reason
that I'm not going to do. But I mean, if I don't know, maybe we'll have a conversation afterwards, and we might go ahead and.
Yeah, afterwards, exactly.
I'll,
I would really say it's
well, we
probably
will.
mood, yeah.
right? We will, but not necessarily LLVM pipe will, right?
True, yeah.
So
Yeah, but I'm not talking about advertising it, but I'm talking about whether the compiler actually should bail out or not. Advertising is pretty much out of the question. That's for sure. Yeah.
all right, well, we can take this offline, I think.
Okay, I think so. Okay, that's about all I had to say. Thanks so far. Any more questions? Any more comments? Okay.